Welcome to the Geometry Unit 9 video for skill number 61. I can extend formulas, area formulas, and use the area addition postulate to find composite area of a figure. We'll begin our notes on page 61A, titled Extended Area or Extending Area. And as you can see on here, what I've done is I've listed the area formulas that we're learning in these sections. We've got the square, which some people think of side squared, but you can also think of it as base times height, because a square is a rectangle, or a type of rectangle, and the area for rectangle is base times height. And actually, a rectangle is a type of parallelogram, which has the formula base times height. So all three of these have base times height as a formula. Next up we have the triangle, whose formula is 1/2 base times height. And you can think of basically a triangle is simply 1/2 of a rectangle. So that's why we get half base times height. Next up we have the kite or the rhombus. And the formula for that is 1/2 diagonal 1 times diagonal 2. So you take the products of the diagonals, multiply them, and cut it in half. Then we have the trapezoid, whose formula is 1/2 of base 1 plus base 2. And then we multiply that by the height of the trapezoid. And finally we have the circle with the formula pi r squared, where r stands for the radius of the circle. We are going to be using these formulas largely to find composite area of more difficult shapes. For example, if I gave you the following shape, you would perhaps break it down into this rectangle that I'm outlining here times this square, not times, plus this square, and then add the semicircle. So that's how it'll look on the skill test. We will piece together composite shapes and find the area that way. Example 2 here says find the composite area. So what we have in this drawing is it appears as though we have rectangle ABDE and a triangle BCD. And they give us the measurements of AE is 5, which means BD is also 5, and then AB is 6, which means ED is also 6, and then they give us the height of the triangle as 8 inches. So I'll write those in there. AE is 5, making BD 5. AB is 6, making ED 6, and then FC, the height of the triangle, is 8. And we can find the area of this shape by adding together the area of the rectangle and the triangle. So the area of our rectangle is base times height, so 6 times 5 gives us 30 for the rectangle. And then the triangle is 1/2 base times height. So our base is 5, our height is 8, so 1/2 of 5 times 8 is 20, making our composite area 30 plus 20, or 50 square inches. In example 3, what we're going to do is find the shaded area. And as you can see, what we have is a parallelogram with a circle taken out of it. So what we want to do is we want to first find the area of the parallelogram, and then we subtract out the area of the circle, and that would give us the shaded area. So to find the area of a parallelogram, we do base times height, and the height is not explicitly stated, but if you think about the circle that's enclosed inside, it has a radius of 3, so the height of that is going to be 6 inches. So the area of our parallelogram is 18 times 6, or 108 square inches. And then the area of our circle is going to be pi r squared. So pi times 3 squared. pi times 3 squared, which is pi times 9, which is approximately 28.27, which means for our shaded area we take the 108 and we subtract 28.27 and we get approximately 79.73 square inches. Alright, the key concepts and ideas for this lesson are basically understanding the area addition postulate. If I give you a shape which is composed of multiple different shapes, we should be able to use the area formulas we know to find the area of that shape. It could consist of shapes being added together, or maybe what it is area subtracted. So what this diagram here is, we subtracted a semicircle from the rectangle. So we should be able to do the area of a parallelogram. I'll just parallelogram, the area of a circle, the area of a triangle, the area of a rhombus or kite, and the area of a trapezoid. I think that covers them all. Parallelogram, of course, would include the square and the rectangle. Alright, this concludes the lesson.